sign language detection using OpenCV. So let's start. Before starting this project, I have done a market survey in which I found that there are applications which do the opposite. Like we give them a normal text and they will translate the text into sign language using a 3D avatar. Yes, here that apps normally text. Now there was one another, like they don't have an application but they have like their own device, a tablet-like device. So that has a special sensor and that all that will translate that sign language into speech output. It will output into speech. So let's start. For this project, I have used OpenCV. In that, you have used Haar Cascade Classifier. It is Haar Cascade is Haar feature-based cascade classifier is an effective object detection method. It is basically an soft object detection algorithm. It is a machine learning based algorithm. So here the Haar means they are the type of feature used to detect the objects. Now, why have I choose the Haar Cascade only? There are also another available. So why did I choose Haar Cascade only? So there are different available like LBP and HOG. LBP is local binary pattern and HOG is histogram of oriented gradients. So in the difference between Haar Cascade and Haar Cascade and LBP or HOG is that the LBP and HOG are faster in training as well as detection of the object, but the main drawback is they are not that accurate as compared to Haar Cascade. Now Haar Cascade detection and training is a little bit slower than the LBPN and HOG, but it is more accurate than this. So the Haar Cascade is used. So in order to train, we need a lot of positive and negative images. So the positive images are the images that contains that object we need to detect, right? And the negative image are those images are the images other than the images that have the object that we need to detect. That means the negative image won't have any image that contains that object that is up in positive image. So next, in order to train the classifier, we need to extract some information. So this information we are calling features. So that feature is nothing but it is a single value that is obtained by subtracting the sum of the pixels under the white box and the sum of the pixel under the black box. Okay. So next, now the initially the algorithm will start with a 24 by 24 image, and we have also used a 25 by 24 image to train the classifier. Now there are two problems, like a 24 by 24 image. Now this algorithm will find features in that image. Now that image after the extraction of features, now that have almost more than 1.5 lakh features, right? And that is a very big problem, because 1.5 lakh features is a lot of features. We do not need that much features, and that also has, for each and every feature we have to calculate the sum and then subtract it. So it is also very time consuming as well as very heavyweight. And during the training, the if you are using the device then like laptop, then it is of no use, because all of the resources will be required during the training. So for first feature, as I said, there are more than 1.5 lakh features. Yes. So and among that features, like almost like most of them are on of not use to, like they are of no use to us, so we have to remove them, right? So in that adabos use, but before that we need to, there is also a second problem, that calculation is a big problem, because for 1 lakh 1.5 lakh features we have to add the pixel under the white rectangle and add the pixel under the black rectangle, and we have to subtract them, right? So how do we minimize that? So for that, the concept of integral image was introduced. Now the integral image, what it basically does is it will reduce the calculation for a box like rectangle, white or black. It will reduce the calculation that includes only 4 values, right? So the calculation is drastically decreased, and the other, we use adabos to reduce the number of features, as most of the features that are calculated are of no use to us. Like for example, here we have these two are best cases of features, like these features we can see here. Now this feature is identified on the property that the eyes are darker as compared to the cheeks, right? So this is like this, black box is on the eyes and white is on the cheeks. This is also calculated the same as this part on our nose bridge is lighter as compared to the eyes. Now these are the best case scenarios that we need these features in order to train for a face image, right? Now suppose if suppose uh, the different feature is calculated here, right? Like the black part is here and the white part is here. Now that feature is of no use to us, so we have to neglect that. So for that, now that the this type of features, there will be a lots of features that we don't need, so we will be reducing or removing that feature using adaboost. Now what adaboost will do is it will, so for each feature that it will find, it will try to apply that feature on the different positive image, right? And it will check if it is a good feature or not. If it is a good feature, then it increases the weight of it, and if it is not a good feature, then it will reduce the weight of that feature. So this way it will reduce the features. Now if we are considering a 24 by 24 pixel image, then it have almost this many features, and adabos will decrease these many features to only 6,000 features, right? So that is a lot of feature are not required, so that we have reduced. Next, now this final classifier, right? We have reduced the feature, we have find the features, so we need, you will use that feature to, will combine this feature, right? So this final classifier will be a weighted sum of this weak classifier. Now why it is called weak classifier? Because it alone can't classify the image. Yes, because we cannot use that weak classifier to detect the object in the image. Now we can use different lots of weak classifier and combine them, and we will form a strong classifier. Now we have the classifier. The classifier is basically it contains all these 6,000 features. Now what we will do is we will take a 24 by 24 image, 24 by 24 window. Now the image can be of any size. It will start with a 24 by 24 window and it will scan through the whole image. So this will You start with a 24 by 24 window and apply all the 6000 features to that window. And there is again a problem. Now these features are a lot less as compared to 1.5 lakh, but it is still a lot of feature. Now the image can be of any size, right? So it does not depend that we only have a 24 by 24 image. In this current scenario, like this world, we almost every picture we have are of HD, right? So suppose it start with 24 by 24 window, so it will scan through the whole image, then it will increase the size of the window, and again, so it is still a lot of features. So how do we reduce this, right? So for this, the concept of cascade of classifier was introduced. Now instead of applying 6000 features on the window, what we can do is we can divide the 6000 features into different stages, and we can apply the stages one by one. Now we don't have to apply each and every stages. What we can do is we can check if the image satisfy the first stage, right? Suppose if the image satisfied the first stage, if it passes the first stage, then it is further passed on to uh, check for the second stage. If it fails the first stage, right, like it is applying the image, it is divided into stages. It is applying first stage. Now it fails the first stage, so what we can do is discard it, right? If it is not passing the stage, we can discard it. We don't have to apply the remaining stages as it is not satisfying the first stage, passing the first stage. So this way we can further reduce the calculation, as we don't have to apply each and every feature to each and every window. Now here is a demonstration. You can see this is a 24 by 24 window. It is scanning through the image. Now if you are able to see, then there is edges. Now here, this is classifier is trained for the face, right? So it will detect the features. This is a feature, right? So see here, it has only 8 stages because this is not satisfying every stages, right? So what it will do, it will quickly scan around the image as it is not finding the face, right? So it will quickly, does not take any time because there are very few stages, and when it reaches here, you can see the speed, the stages will increase. The 18 stages, the stages are increasing because it is finding the uh, face in the image. See, it will take more time here because it has to apply all the stages, and it is passing the first stage, so it is applying second stage. It is passing the second, and then it is applying, see, 22 stages. Now once it will scan through the whole image in 24 by 24 window, what it will do is it will increase the size of the window. See, the size of the window is increased. So why do we do this is because in image, right, the every object does not have the same size, right? When we are training the classifier, it may have different size in the real world, as we are training the classifier for a fixed size, right? So what it will do, it will increase the size so that it can find the different size of the object in it. So at final it will detect that it is face. So that was it. Now the OpenCV has function for that. So how to train? So I have trained the classifier with positive and negative image to get. Now this is done with the console. So now we don't have to do it with console, as we have a GUI application for this, which we only have to give the path of the folder which have the positive and negative image. So we don't have to write any of this. It will directly uh, gather the information from the folder. Now how to use. So for using the classifier, we have to first point out to the file, the classifier XML file, so where it is stored. So this is used to point, this function is used to point out to the classifier file. And what we will do that we have class point out to that classifier file. We will use different function, detect multi-scale, that has three parameters. Image, the first one is the image on which we want to find the object. The second is the scale factor, and third is the minimum number of neighbors. Now this is the image from which we want to find the object, and this is the scale factor. As we have discussed, the classifier was trained with a limited size of the object image. The image contains a limited size of the, it does not have every size of the image object, right? So in real world we won't have that scenario, as object may be of any size, maybe smaller, maybe bigger. So we have to use scale factor. So it will scale the image to this and this percentage, and this is a minimum number of neighbors. So if we have more than one of that object in the image, it will, minimum number is 5, so it will show only 5 objects. The above function, what it will do, it will return 4 values: height, the x coordinate, y coordinate, height and width. So we can use that 4 values to draw a rectangle around our object, right? So that was it. And let's do a demo. Let's see a demo. Now as you can see here, this is a rectangle, so we have to place our hand in this rectangle, the square. So this is A. According to the sign language, this is A. This is B. This is C. D. E. F. Now sometimes you will see this flickering and different character are print out. So what this is, because it is finding similar feature in a different classifier. So this represent O, so this is detecting O as well with F, right? G, H, I, K, L, O, P, Q, T. If some of it doesn't work, as I am sitting in different lighting conditions, the light is very less here. So Let's put it up. So that was it, sir. Thank you.